Right, so I've got my generator tucked away there, but who the hell wants to drag one of those things out for short-term power outages, right? The power is obviously restored here now, but it's been out for a wee while, guys. It's about 0 degrees outside, so it's cold enough that the house starts to chill in a hurry. Really, I've found that this is more than adequate for short-term power outages, right? It's just a wee cheap inverter, 600 watts. The specs say that it'll give you an 1800 watt surge capacity, and all of that is nice to know. But all I really need to know is going to run the blower on my fireplace for, as I said, it runs it for a couple hours. You know, you're usually okay. Again, the power's back on, but kind of takes the drama out of the video. But that's just the reality of the matter. I'm happy it's back on. So I just run the power cord from the inverter, obviously through a lengthy extension, and the blower in the fireplace. It's just a 120 line, of course, right? And just a standard plug when I remove it from the. Looks like I need to do a wee bit of dusting in here. Sorry about that. But more than adequate for both start the blower, and actually I can crank the. I don't normally have it this high, right? In fact, let me turn that down a bit right now. Usually regulate the flame a wee bit lower than that, you know. But since we were onto that, I can turn the valve up to the maximum heat, and the blower can give us plenty of capacity as far as keeping the house warm. Dirt cheap setup. Just keep an eye on the battery voltage of your car, of course. The inverter itself has a low battery cutout, a couple of wee emergency lights.
Pay attention, son, this is for your own good.
Unloaded, you can see it's actually nothing on it. Let's just turn on the inverter itself. It's about 0.3 of an amp. So yeah, 0.3 of an amp at 12 volts, 12.5 volts is, let's call it 5 watts ish. Just turn it off here. I'm going to just plug in the blower. I just want to see what the surge current is. Sorry, yeah, I know you're at frame here. So again, this is with the load actually attached. Let's see what it actually goes up to. So with the blower speeding up, it should come down. So I'm just going to drop the battery voltage here. Keep an eye on the color of the LED there.
Pay attention to me, boy. I'm not just talking to hear my head roar.
The color of the LED is already starting to change to amberish. It's 11.7, 11.8, and by 11.7 it's red. So this actually gives you quite a good idea what the state of your battery, obviously it's a power supply here for demonstration purposes, the state of the battery with respect to its voltage is concerned, long before you're going to get the audible alarm. So the audible alarm, I'm going to continue to drop the voltage here. Obviously you can listen up to the soundtrack. 10.8, 7, 6, specs is 5, and right at 10.5 there's the alarm. So we'll just continue to drop the voltage. The spec sheet says 9.5 for cutout, plus or minus 0.5. So we'll see where it actually cuts out. That's 10, 9.9. So it's dropped the load. It's dropped the load at 9.9 volts. And interestingly enough, if you bring the voltage back up, if it recovers, it will not turn the load back on until you actually cycle the switch. I'll show you that what I mean by that. Let me bring the voltage back up. Turn it on. So there it's operative. Again, we'll go below the cutout. There's the warn. There's the cutout. So if the battery voltage actually recovers, it won't turn the load back on until you actually select the switch. Off and back on. Which makes sense because you might end up with a load cycling on and off, and depending on what the load actually is, that could potentially be not ideal. What do you think, Yoko? Good enough?